So, welcome back. My apologies again for missing class on Thursday, but now we're back and we are ready to continue learning about Node. So last week, we went through a quick introduction to how Node works, right? This is JavaScript that we run on the desktop or the server. It doesn't run in the browser, so it's a different kind of environment. And it also runs in a different way, right? Like instead of being a blocking language like PHP or Python, where operations that touch the network or the hard drive actually halt the execution of your script and they wait for you. In Node, they don't wait for you. And so the way that we deal with those operations is we pass in a callback function that will be called once they complete. And so that way, Node will let us know, hey, this thing is done. Here's the result for us. What we're going to talk about and work with this week, we're going to be spending some more time with the request module. It's a really nice module for kind of like working with a lot of these different kinds of you're on candid camera, by the way, there, Patricia. So sorry about that. One of the things that, in addition to callbacks, there are other situations that we get into when we need to process multiple files, or when we need to be notified not just once, but multiple times that something has happened. For example, if we're making a request, we may want to find out when we've gotten the headers for that request, because maybe at that point we can actually stop and we don't need to download the rest of the message. Maybe the headers are enough. Or if we start opening a file, maybe we want to deal with that file line by line instead of having to load the whole thing. Loading the entire file would take a lot of memory, but loading a single line of that file is very quick, and then we can just drop that right out of memory and we don't care about it. So we are going to deal with a couple of new abstractions, actually 3 new abstractions for managing this problem of non-blocking input and output in Node, what we call asynchronicity, where Node does not wait for us. Instead, we have to pass in functions and allow it to manage these kinds of non-blocking state. But to do that, first of all, we're going to review really quick. So if you look, I've got my terminal open, my git bash. I've gone onto my desktop. I have made a directory. I'm going to zoom this up a little bit so that you guys can see, because it's a little bit small, I think. There we go. All right, so that's kind of weird. It decided to go off screen. I'm not really okay with that. Okay, that's not also helpful. I'm a professional, everyone. All right, anyway, I created a directory in here. I cannot get to my menu, which is super great. I'm going to have to close this and restart it. But I created a directory in which, and then I navigated into that directory. And that's how I was able to, here we go. Let's turn that off. Much better. Cool. So now I'm going to enter, I'm going to type cd tilde to go to my home, which is my user directory on this computer. Then I'm going to navigate into the desktop. I created a directory that was called ITC 298. Here we are. And if I type ls, you'll see where I've made a file inside there. It's called index.js. So I have a JS file that's waiting that we're going to write a little bit of JavaScript in today. And actually, I'm going to create a second file that we're going to use as a module to kind of explore this asynchronicity, because we need a way to test it, but I don't necessarily want to immediately jump right into like loading the file module. So in addition to your index.js, let's create a second file. I'm going to save this as wait.js. And this is going to be a second module. What's great about that is it gives us another chance to practice creating modules, right? So we can talk a little bit again. We can review how require works. So in our wait.js, we're going to create a function that will wait a random amount of time and then pass that random number back to whatever process. So basically, it's just a thing where you call wait, and then it will eventually call back, but you don't know how long it'll take. And so it's going to simulate, if we were to perform a file operation, anything that would take some time, or a network operation, right? So our function, we're going to say var wait is our function. It is going to take a callback as its last argument. And it doesn't take any other arguments, right? All we need to do is give it a callback that we pass in for it to do its thing. Actually, I'm going to reserve a space for input, but we're not actually going to really use, we're just going to pass in dummy input. It's not going to do anything with that. Or maybe we'll pass it back in. That's a better idea. Cool. Okay. So this wait function needs to wait before it calls back. If I need to wait in JavaScript, whether that is the browser or here in Node, who can tell me what it is that I use to tell the script to resume after a certain amount of time? Huh?
Break.
Not break. Set timeout. Yes, thank you. So we're going to use the set timeout function. And set timeout takes two arguments. The first argument is a function of, okay, when the timeout is complete, run this function. And the second thing is how long it should wait. And for, just for lack of anything better, let's just make it wait 1 second right now. Doesn't really matter how long it waits. We're just going to say 1 second, you're cool. And inside of this callback, we need to notify the thing that called wait and tell it, okay, like I have finished whatever process it is that I'm doing, and here's the result, right? So I'm going to call the callback to do that, because by calling the callback function, that's how we notify things, right? When it's asynchronous, instead of just being able to set something equal to, we use this function that was passed in and we pass back. We just hand back the values that we want. So null is our first argument because there were no errors, right? Whenever we call a callback, we normally pass in, if there is an error, it's the first argument. And then after that goes whatever data, and we're just going to pass the input. We're just going to echo it right back. So when I call wait and I pass it a number or a string or whatever, it's going to wait a second, and then it's just going to echo that right back to me. But this is going to simulate for us the process of going out to the network or the hard drive to do something. And in return, we get whatever it is back. And then later on, we'll do this with a real process where we'll actually like talk to the network. We'll like ask for google.com or something, and that way we can actually play with this. And then we need to export this so that I can use it in index.js, right? Because otherwise, I can't do anything with it. If it's locked in wait.js, it is unavailable. So who remembers from last week, how do I make this function available to other modules? Can I get one person? I just heard I heard the answer in there somewhere. The answer is that we need to set module.exports, right? That's the special value that Node gives us. Now, module.exports is normally an object, but objects in JavaScript can be anything. Functions are objects. And so since this is such a simple module, we're just going to say that its exports is the wait function. Ooh. And that means, that means that when I require this module, what I will get is this function, right? It's not wrapped in an object. It doesn't have anything alongside of it. It's just the function. This is a perfectly normal pattern that you will see things use in Node. Cool. So now let's actually use this. And this is the other thing that I heard people shouting, so we're all on the same foot. That's good. Back in our index.js, we need to load this module so that we can actually use it. So we're going to create a variable to contain that value that we exported. And we get it by requiring it. So we use the require function. If this were a module that we installed from npm, we would be able to just write the name of it between the quotes. But since this is a local module that we wrote, we need to start it with a dot to tell Node I'm loading this from another file that's located right here in this folder. You don't need to go to the node modules folder. Just stay right here. So we're going to require wait. And then real quick, we'll just use it. So we'll say wait. We're going to pass in some information of some kinds. And then our callback function will log that information back out. So you're going to notice when we run this that, of course, technically, during the 1 second between when we call wait and when our callback is actually invoked after the timeout expires, Node's not doing anything. And if you're used to other languages, you may feel like it should maybe quit because it will automatically exit once that timeout finishes. Node will keep track of how many, if you have timeouts, if you have network requests, it keeps track of those and it doesn't exit until they close. So there are going to be times actually where we will have to manually shut down our node process because there are outgoing timers running or there are pending requests. But for the most part, we should be able to run this and it should just work. So back on our console, in the directory where we save this file and using ls, I can see that yes, I do have these 2 files here. I can now run this by saying node index.js. Meaning start the node interpreter and feed the index.js file. That will in turn require wait.js. It'll use the wait function. And we should see after a second, there we go. That took actually a little bit longer than, because node had to start out. So technically, I guess we could have logged out like when it was actually starting. We could have been like console.log ready. And that way we should see that it is actually a second, but the first time you start it, it's a little bit slow. And I will scroll that up so that you can see. So this is our bog standard kind of asynchronicity, right? We have a very, very simple invocation pattern. When we start a process that takes some time, we call its function and we pass in a callback to be invoked once that process has been completed. On the other side, it receives this function as a callback, and when it's done, it actually invokes that function and passes back an error, if any exists, and whatever result it had. So if this were a real network request or a real file read or something, we would get like the contents of the page that we requested or the file that we had read. In this case, we're just echoing back whatever it is that we sent in. So it's just like a big empty room that we echo into. Does anyone have any questions about this? This should all look pretty familiar. We talked about a lot of this stuff last week, right? So the patterns of error first callbacks, callback is the last argument, standard way of handling asynchronously. Right? Cool. All right. So let's talk about something that makes this more complicated. Because I love to make things more complicated. So in this case, we have a single item, and we need to wait for it to return. And that's fine. Like that's something that you're going to do a lot, right? You'll have a single piece of data, and you'll need to act on it. But if you've been programming for any amount of time, you know that we also have issues where we need to operate on like a collection, right? We may have an array of items or a hash of items, and we need to do something to all of them. When we're in Node, that becomes a lot more complicated, right? Because we would either have to write something that basically goes through them one at a time and kind of like handles each one after the other and increments a variable. Like we would have to manually explode that loop out and keep track of where we are in the array. Or we would run into a problem like this. Let me show you what we're going to do here. So let's create a quick array just to demonstrate this. So I'm going to say var fib is a Fibonacci sequence. So 1, 1, 2, 3, 5, 8, 11. good old Fibonacci. And I'm going to say var output is equal to an empty array. And I want to process this Fibonacci, I want to double it. So I'm going to go through and for each of these numbers, I want to take each of these, multiply it by 2, and push it into my output array, right? And in regular JavaScript, this would be really, really easy to do, right? We could just say, I'm going to go with the functional form. If you haven't seen this before, then I apologize, but this will be good for you to see. I'm going to say fib.forEach. The forEach function gets called with each item. And I might say output.push item times 2. So this is what we would call a synchronous loop. And then at the end, we will console.log out the output. And we can call this a synchronous loop because it doesn't pass us by, right? Like each of these is going to execute one after another. It's going to do it in order. There's not going to be any delay. The forEach is not an asynchronous function, so it just runs, and it runs directly through those items and handles all of them in order. I don't have to worry about, like, when I get down here to line 16, I know that all of this code will have already run. This is blocking code. And so when we run this, we should see, going back to my console window, there we go, right? Like here's my updated Fibonacci sequence. And then you can see where a second later I got information hanging out here because that was on a delay. But what happens if instead of being a process that's synchronous and blocking, because most of the things that we do in Node are not synchronous and blocking, right? Most of the things we do are async. What if this process was asynchronous? So instead of being able to just push each thing, what if we had to wait? What if we had to wait and we would pass in the item, and then when we got the result back, so like if you imagine that these are URLs and we're requesting a whole set of web pages. And then once I get that item back, that web page or that file is completed, downloading or reading off the hard drive, then I push it in to output multiplied by 2, right? This is an asynchronous loop now. And for those of you who have not run this yet, what do I see in my console output when I'm done? Like if I run this, don't run it, but actually like who can guess? Like what am I going to see when I console.log it out on line 18? Sorry, what?
A longer pause?
Not exactly. I will see a longer pause, so it will hang out for a little bit longer. They're not in order? No, it's actually even worse than that. Mike, what do you got?
There's absolutely nothing there.
There's nothing there. Why isn't there anything there?
Because it's not blocking. So by the time it gets to line 18, it hasn't actually got any information back yet.
Right? Like it gets to line 18 like right away. It doesn't, remember, asynchronous means it doesn't wait for us. So although we execute this loop and the loop finishes, each of these individual items is still waiting for another second by the time we get here. So the output is empty. There's nothing in it. Right? I keep going to my Kindle and set that to my... So there we go, empty array. Like, yay. So that's kind of difficult, right? Like we can imagine now that anytime we had to work with a list that might be like a list of files that we want to read off the hard drive, or a list of URLs that we want to download, a list of database queries that we want to run. When these things are asynchronous and they're in a list, now we need tools to handle this. Now it is possible to write code manually that keeps track of, oh, okay, if I called wait on this, then I can use a closure to keep track of which item in the array is, and then I can keep track of how many I've gotten back and when success reaches the input length, whatever, right? This is gibberish. You don't want to write this. You don't want to test it. The best thing we should do is we should take advantage of one of the things that Node provides us with, which is somebody's written a module to handle this, right? We don't have We don't have to learn how to write complicated asynchronous code. We're just going to grab a module to do it. So we're going to use the async module. And the async module is specifically written to handle asynchronous cases like this. It lets us handle lists. It lets us process chains of asynchronous things. Remember how we got the callback pyramid of doom, right? Where it kept going in the more things that we changed. Using async, we can actually create a waterfall so that those things do not have to be indented. Instead, they just proceed nicely down the page. And even though they don't technically run that way, as far as our source code is concerned, they look that way. And so they are more readable and easy to understand. Before we install the async module, I want to talk a little bit about the way that we install modules. Because on Tuesday last week, we installed a couple of them, but we just kind of, I think, installed them just real quick, right? We just did this thing. And I want to talk about how we actually want to do this sustainably, because you're going to be working on your projects, or if you're working on your labs in this class, and especially if you want to work on your lab and check it into GitHub so that you can keep an eye on it or share it or use it as a portfolio piece, you're going to want to check in an application that can be restored from that source code, right? You want somebody to be able to clone your repo and get your application. But you don't want to check in your node modules. Does anyone know why? Huh?
A lot of lines.
It's a lot of lines of code. And they are, NPM is, it's immutable, right? The idea is if you request a package from NPM and you say, I want this version, you will always get the same code. Node does not let you say, oh, actually version 0.0.4 is different. You have to increment the version number. So because it's like that, when you install a package, you can guarantee that you're getting the exact same code everywhere you go, right? NPM will make sure that everyone gets the same thing. So if you check it into GitHub, it's just noise. You're just creating needless duplicates of these files for no good reason. And you're just clogging up your repo for no good reason. It's unprofessional. So what we want to do is we want to create a note, basically. We want to create a manifest of what are all of the modules that this application uses, so that when somebody downloads it, the modules don't come from GitHub, but they can run one command and get all of the things that I have as dependencies. And to do that, we create a package.json. Package.json is our manifest. It's just a normal JSON file, and you can write it manually, but luckily you don't have to. If you go to your console and you're going to type npm init for initialize. And when we run this, it's going to start asking us some questions. It's going to say, this will walk you through creating a package.json file. It tries to guess sane defaults. Yes?
You can see that side of the screen.
Okay, I'll move it over. There we go.
How did you want to do the file for the wrong file I commanded? I forgot. I did a wrong file. I did a command with C, wrong, not name. So how can I go back?
Oh, CD dot to go up.
Oh, okay,
yes.
thank you.
Yes, sorry. Didn't understand what you were saying for a second. Okay. So npm init is going to create this package.json file. So it's going to create a manifest. And that manifest is used for two things. One, it lets us install things with one command because it remembers what modules we've installed. But two, this is how we actually create our own modules and publish them to npm, right? If you create something that's really useful and you want to share it, for example, I have my crappy codename generator that I use at work. I can publish that to npm, and then anyone else who wants a crappy codename generator can just use my module. They don't have to download their own, which is a really helpful thing to have. So that said, when you npm init, it'll ask you these questions, but you'll notice that it'll almost always have in parens, it'll have a suggestion. And since the JSON file is just a text file, you can change all this stuff later. So one thing I usually do, honestly, is if I'm initializing for the first time, I just hammer enter a lot. I don't really care. I mean, I'm going to go back and change this stuff anyway. And or I don't have anything, right? I don't have a test command. There is no test that I'm going to run yet. I don't have any automated tests installed. I don't have a Git repository yet. I don't have any keywords. If you're logged into Git, it'll pre-populate your author, so I can just hit enter and go past that. It'll ask We're about to create this. Is it okay? Hit enter again. It'll say yes. And now you should see that if you ls, you should see that there's a package.json. And we can even open that up in our editor to take a look at it real quick. So here we go, right? Here's my manifest for this application. The name of it is ITC 298. The version is 0.0.0. There's no description. The main is just the index file, whatever. Empty, I don't care. Now that we have the package.json, we can install modules and we can tell NPM, remember this module, and because this file is here, it'll have a place to keep track of all the things that we've installed. So let's install the async module, but let's do it in a way that it'll remember. So when we install a module, from our command line, we type npm install, and we type the module name, but don't hit enter yet. We need to tell NPM, hey, I want you to remember this, right? This is important. People who use this application are going to need to have async installed or it's not going to work. So after I npm install async, do -- save. It goes out to the internet. It downloads. Async is very small, so it takes like no time at all. There's no dependencies. And it's downloaded. And if we look in our folder now, the folder on our desktop or wherever it is that we created it, you should see that now we have, let's view this as extra large. Whoa, these icons are huge. Let's maybe go with large icons. There's now a node modules folder, right? And if we click in, there's async sitting there for us. But in addition to creating that folder, we now also have a new set of lines in our project.json. Right? It reads dependencies, async, and here's the version number. So now it's keeping track of what modules we've installed. Yes, Victoria. Oh, so you may need to do a sudo install. Yeah. That's yeah, I'm sorry. And space and then type of install So yeah, if you are on a Mac, you may need to sudo this command because on a Mac by default, Node installs with administrator privileges. So you may need to say sudo as in sudo. Sudo means as a super user do something. So your command would be sudo npm install async -- save. There are ways around that. We can talk about it later, but for right now, just sudo the command. It's fine. It's not a big deal. Okay. Well, on Windows, you don't need it. Yeah, so on Windows you're fine. It's only for some reason it's only a Mac thing that requires sudo for. You still have an error. Okay. No, you're good. It's not right. Okay. So why? Let's simulate. So what happens now if I download this from GitHub? Like, let's say that I finish this application. I check it in. I'm like, okay, cool. I'm done with my application. I check it in. I want to make sure that node modules doesn't show up, so I'm going to add it to my git ignore. Feel free to ask me about. There's also a guide in one of the intro to node documents talks about how to set up your git ignore file. Or you can look at my repo and it's actually just in here, right? Like the git ignore for me has node modules. So this is node modules will never be checked in my repo. If I were to delete this, then that's what this would be like if I loaded this from source, right? Because I wouldn't check those in. So I would get my files, but I don't get the node modules folder. How do I install the things that all of the modules that I need? The cool thing about it is once those things are in your package.json, right? Once those dependencies are there, I don't have to remember what they are individually. Instead, I can just say npm install. And then it will look at the package.json file see that it needs async, and it'll install anything that's listed in dependencies. So as long as you install your stuff with -- save, you don't have to check in your node modules folder, because anyone who downloads your code can just run an npm install, and everything in your package will be downloaded and installed to go with that application, right? So this is a cleaner, nicer way to work rather than checking in thousands and thousands of files and thousands of lines of code that are the same as everyone else's copy of those thousands of lines of code, right? There's no point in putting that into source control. Questions? Yes, Mike.
I know it's probably beyond the scope of what we've already talked about, but if you have a node module that you have put in your dependencies and it requires your dependencies, it also downloads the dependencies of that node module.
Right.
Okay.
Yeah, so if the module itself depends on other things, Node will look at its package.json and look at its dependencies list, and it will recursively grab those, because it can go many, many levels deep, right? Like things can require other things. So that module can go lots, but it'll take care of all that for you. All it needs to know is the base level of modules, and then it will fetch the rest. Yes?
So if you're on top level and you install something that requires like jQuery, and then you go 2 levels back in, will it reinstall jQuery, or will it realize it already has installed up?
Normally, it will install a fresh copy.
Okay.
And the reason why it does that is because in Node, what we want to do is we want to be okay with the idea that one module could use like version 2 and something else could use version 1. They should both be able to have their dependencies, so they each get their own copy of it, so that you don't have to worry about, well, this one needs version 2, this one needs version 1, which one wins, right? So instead, it means that it takes up a little bit more hard drive space, but hard drive space is cheap, and programmer time is not. So by making sure that we never have a dependency conflict, by just recursively installing everything and duplicating it. There is a command that you can run where it will go through, look for things that are shared, and move them up so that it'll stop installing duplicates. But there's not really a good point to it, to be honest with you. Like I've tried it and it never really saves that much space. So it's always just kind of been a waste of time. Cool. Any other questions? Okay. Now that we have the async module installed, let's actually use it to make this loop work, right? Let's make it do what it is that we want it to do. So we are going to make this an async loop that works. So first we need to get our module. We just installed it from npm. Should be sitting there in our node modules folder. So we can now say var async is equal to require async without a J. And the async library comes with this enormous range of things that are useful for us to work with. And usually if you search for async, you'll find it. But it comes with this enormous number of stuff that it can do, right? Like it can do each, map, and we're going to talk through a bunch of the stuff that it can do. This is also one of the things that is in, if you look in the ITC 298 repo, there's an async directory, and the root file in here talks about how to use 2 of the most common things that we use this library for, right? We're going to use the each for processing lists, and we're going to use the waterfall for doing things in order instead of having the callback pyramid do. So now that we have loaded it, let's work with our Fibonacci sequence. So we're going to use, instead of using the native for each, we're going to use a special each that async provides that knows about asynchronicity. And the way this works is we are going to say async.each. And the first parameter to each is what are the things that you want to process? What's the array? So we're going to pass it our Fibonacci sequence. And then in here, we're going to say, what do you want to do to each item in the array? It's the same as our regular each loop with one little difference. So we're going to get our item, but then we're also going to get a callback. right? It's an asynchronous process, so we need to let async know when the thing that we're doing that takes time has actually completed. And in this case, we're going to call the same way that we did before. We're going to call waits with item. Going to get our callback with the error and the data. And then we are going to call that callback with data times 2. So now for each item in our array, we're using the same basic each structure, but instead of just doing things synchronously, we have a callback that we call back once it's done. So we're building that chain of callbacks again, right? Functions that call into functions instead of using equals or push. Actually, what we should do here is, let's come back to this. Let's do, actually, yeah, let's come back to this. Let's do output.push for right now. We will come back to that. Data times 2. So what we don't want to do is we need a way to know that all of them have finished waiting and that we have pushed all of these new items in, right? Like that's the goal, is we need to know when it's done. So in addition to the first function that we pass in, which is our iterator, what do we want to do to each item? Typical for a for each loop, right? Now we pass in a second function, and this is the function that will be called when all of our items have been completed. So this is when we are actually done with waiting. And in this case, now if we console.log output, because this function waits for us to be done, in this case, we'll actually have all those numbers. Actually, we'll have twice of them because the first loop is still running. So we probably want to comment that out. But in this case, now we will actually have this. We couldn't put it outside. We needed to make a second function, but now async.each will keep track of our loop for us, right? Because we're calling the callback to let it know. In fact, I need to do that. Callback. This stuff is, by the way, you're watching me make mistakes, right? When I forget to put the callback, you're watching me do stuff wrong. This stuff is complicated. I want you guys to know that it's tough. And you should not feel bad when you're like, my brain hurts at the end of the day, right? That is a natural way to feel about this way of writing code. It's not like anything else that you've done. Unless you have written like Twisted Python, which I'm pretty sure none of you have done, right? Like none of you have done anything like this. It's very different. And even I've been doing this for about 4 or 5 years of Node now. I still make mistakes like this all the time. So it's okay.
Let's see line.
You can see what?
Line 3.
You can, but why would you need to? Okay, fair enough. Okay. Yes.
How did you decide which variables to pass in the function?
How did I decide what variables to pass in?
Yeah. Sometimes you pass in callbacks, sometimes you pass in dates.
Oh, so this is not actually, I'm not making that decision. The callback is, do you have specific lines in mind?
Yeah.
Right, because this is a callback function. So the first argument has to be an error, and the second thing has to be the result. So right here, because this is a synchronous loop, I don't have a callback because it does this blocking, even though that doesn't work, right? Like this code is not good because it doesn't work async. It doesn't understand that we are waiting inside here. And I mentioned earlier, right, that like async is infectious. So that's why here you see that like when we deal with things that are asynchronous like wait, that's why we now can't use a regular for each, because now the fact that this function is asynchronous infects this outer function too, right? Like they have to be async all the way up the chain. So that's why we end up in a situation where like output was not correct. Now it will be correct. When we get this callback, we call it to let async know I'm done with that item. And it's keeping track how many times has that been called. When it gets that function called enough, once per each item in the array, then it knows that we're done, and it'll call our second function here. There's no arguments to this function. It gets an optional error. I don't care. We're not going to pass an error. We're totally in control of this. So for right now, I'm playing a little fast and loose with it, but let's go with it, shall we? Okay. We run this real quick. Lower this window a little bit because it's way too tall. So I'm going to run node index. You can see that it's going to wait a little while. Cool. And so now we have two of them because the first loop is still running. So so it's pushing things in, and then it does it again in our second loop that works. But now we log out once it's done, right? That second callback, the async library lets us know that all of our items have been processed. Now we can log out the output and we'll actually see things in it. Yes?
So on the output.push, the item, should that be data or items? Is that?
So I'm sending the item, which is each thing in Fibonacci. I'm sending it to wait, and then I'm just getting it back.
So when you use it in output.push, should that be item or?
They're the same thing.
Oh, it's the same one. Okay.
Yeah, because when I pass something to wait, I get it back a second later, right? Like there's not. Later on, we'll deal with this in a real way, but like right now, this is kind of like. Okay. Yes.
I just had a question about so you're passing an item,
Uh-huh.
and then when you call back, what are you pushing out as callback or into the object?
So right now, callback doesn't return any values. It's just to let async know that our process is done with that item. Because otherwise, it has no way to know that we're finished with whatever it is that we're trying to do. So right now, but what we're going to do right now is we're actually going to convert this to a better method of working with it. Okay? So in this case, we had to create this output, and then we push things into it. But that doesn't actually guarantee the order, right? Like, what if our wait function changed a little bit? By the way, I'm gonna comment out line 14 so that we don't get double the items. But so we've got wait right now, but what if wait, instead of waiting for a second reliably, what if it waited for a random amount of time? So I'm gonna say math.random times 1,000, and then I'm gonna round that because it's gonna really want an integer. So I switched over to my wait module and I changed it so that instead of waiting for a second every time, it waits for a random number of milliseconds between 1 and 1,000. Could be any amount of time in there. So this returns a number from 0 to 1, multiply by 1,000 to get from 0 to 1,000, round it off so we get a nice whole number. So now we have a wait that is unpredictable, which is usually the case, right? Like when you request a web page, you can say that on average, right? Like going to Google takes like 200 milliseconds, or going somewhere takes a certain amount of time. But you can't actually say that it's always going to take the same amount of time, right? So if you rely on the fact that it's going to happen in order when you fire off a bunch of requests, that's not the order that they actually come in, right? Like, and you'll see this sometimes if you open up the network tab in a browser, right? You're going to see that like files that you start downloading, some of them that are further down the waterfall will still get done first because they were faster or because they were smaller, right? Like if you were downloading a page, it might start downloading a movie, and then meanwhile it downloads a bunch of like JPEGs that are really tiny before it finishes with the movie, right? Yes.
Sorry, I might be interrupting the wrong point here, but when we ran it the last time, I actually expected it to go ahead and wait for a full second for each of those 6 items in there.
Well, they all waited for 1 second.
So
But,
yeah.
but they all started at the same time.
Oh,
So they waited for 1 second total.
got it.
Yeah, they're not serial. We're going to get to that though. That is the thing we're going to do. All right, so when we do this now, before we've been getting two of them, but the weights, since they're all for the same amount of time, they all finish in the same order, right? But what happens when they don't? Now that our weight is random, oh crap, like our array is all out of order, right? So this is not good. This means that asynchronous processes are not only bad because they're not only difficult to think about, they're not bad. That was a terrible choice of words for a node course, because otherwise we're in for a rough time. They're unpredictable. They can be difficult to think about because they not only take a certain amount of time so that they don't proceed like down the script the way that you may be thinking of, but they also can happen out of order. Luckily, async, again, will manage this for us. All we need to do is make a couple of changes. And they're very similar to what Doug was talking about earlier, right? So right now, we have been pushing this data in, but because the callbacks happen in random order, the push is happening random, and that's why our stuff is getting shuffled. So what if instead of using each, we used map? Has anyone used array maps? I know that some of you in my JavaScript class have been forced to use array maps, right? Some of you? Shake your head at me, come on. All right, so array map. The each function on arrays goes through and does something for each item, right? It goes through an order. But it doesn't like save it. If you want to save the output of an each, you have to do it manually. The point of a map is to say, if I have A, B, C in an array, and I run it through a map, then it allows me to create a second array where for each item, these are A prime, B prime, C prime, this is a change happens, but they end up in the same order, right? It creates a map creates a new array from the previous one. So we input one array and map creates a second one, and whatever we pass into the map defines how it changes from one array to the other. This is a complicated thing to explain when I'm rambling up front, but it's actually not that bad in practice. The change here is very simple. We're going to get, instead of pushing this directly into the output, we're going to call our callback with actually the line that I had right above it. So inside of our waits, async will keep track of which item we're dealing with, and we just have to let it know that the result of processing this item was this value. We don't have to know where in the array it was. We don't care, right? It doesn't matter whether it's the 5th item, the 7th item, the 700th item. We just call the callback after changing this to map, and it will make sure that it ends up in the right spot in the new array. Once we've done that, we do need to change. Now we're not pushing these into output. So we need to get that array back, the new array from the map. And we get that from our final callback. So we're going to call it mapped. There we go. So we're telling it for each item in here, pass it to our function, we're going to do something with it, and we will call our callback with the results of processing that item. We don't care where it is in the array, we only care about what its value was and what its new value is. And then in the end, we will get back a new array that is in order, because async will keep track of the order of the items as they were fed out of one array. And then as we call the callback, it knows, okay, for this callback, it is this particular item, right? It keeps track of like item 0 becomes item 0, item 1 becomes item 1, item 2 becomes item 2. And it creates a new array for us that's in the same order. Make sense? Yes. Yes, absolutely.
Sorry,
Oh, you want to see weight? Sure. And then Patricia, I'll scroll it up for you in a second.
I'm confused, why do you use the match function?
I use the map function because,
Not math, math.
oh, math? I use math because that's how I get a random number. I don't have a good reason for it other than that's where all the math functions live, and that's how you get random numbers in JavaScript. So.
Wait, but the number is the same. The output is the same.
The output is the same, but this is the amount of time that we wait. We're feeding this to set timeout. So we're telling it to wait for a random amount of time. Okay, I'm gonna go back to index.js for just a second. How far up did you want me to scroll? All the way. Right there, dang, okay. So map is one of our most common uses of the async library, right? We have an array. So for example, basically what map does is it transforms, right? It takes one list and transforms it into a new result. And there are lots of places where this actually has like super practical applications. It's not like some crazy computer science thing. For example, if I have a list of URLs and I want to get all of those pages, map will take an array of URLs and return an array of pages in the corresponding place, right? So it gives me a way to say, okay, for each of these items, turn it into this other thing. And there are lots of other things that async can do, right? Like it can do eaches, it can do batch processing, so it can do each limit where it takes a whole list, but it only does it in like groups of 10 in case you don't want to like flood your broadband connection or whatever. But all of those are kind of variations on a theme. When it all comes down to it, every list operation in pretty much any language on earth reduces down to two things, right? There's map, where I take one list and I create another, or I do something with it. I mean, if you think about it, an each loop is just a map where I don't care about the result. If I just throw it away at the end, it does the same thing, right? Like it handles each of those items in order and it does something for each of them. And then I just don't care about what the final result was. I don't call the callback with anything, but that's all a map is. The other thing that is a fundamental list operation is a reduce, where if I take 1, 2, 3, and when I feed it through that, I get a final result of like 6 because I added these numbers together. That's a reduce. So you have two kinds of array operations in every single programming language. Map, do something for each of these items, and optionally give me the result for each of them. Or reduce, take this whole list and turn it into one value by adding it up, by doing something to it. I don't care. Like the operation is not actually important. It's the concept that we care about. Make sense? Questions? Okay. So as I mentioned, there's a lot of stuff. Like if you Google for async, you're probably going to end up, I don't actually know how this is pronounced. The guy who writes the async library, it's like Callan, I think. I think he's Irish, actually. It's whatever. It's not actually important. Anyway, the point is there's a lot of stuff here. And it's actually pretty well documented, right? Like if we were to go to map, it'll tell you, okay, so map produces a new array of values by mapping each one through this function. It gets called with these arguments and error and the item. Gives you all the arguments, gives you an example, right? It's very easy to read through the documentation. So I would really recommend, you're going to need on Thursday, we're going to be using this library and we're going to be talking about how it is that we actually handle asynchronicity using this for lists. But there's a whole list of stuff that processes items one at a time. The other thing that I want to talk about are these things that are listed in the documentation under control flow. And the control flow section of async handles a slightly different use case, right? So map, reduce, each series, each limit, all of these things handle arrays. But async is also useful to us because it helps us fight the pyramid of doom, right? It helps us write a series of asynchronous processes to guarantee that they will happen one after another. So let's take a look at an example of that real quick. Let's say down here that I wanted to, now that we have our random weight, I want to wait random amounts of time or like download files, and then I'm going to log out like 1, 2, and 3, right? So I'm going to say wait. I'm going to pass in, it doesn't really matter. Like I'm just going to pass in 0 because I don't care about it this time. Function air data. I actually don't care about these either, but we'll keep them in there. Console.log 1. And then once that's done, so if we imagine that like maybe I have a process that is multiple steps, but those steps are asynchronous. So I need to log out 1, 2, and 3. Well, if I were to write it like this, where I said like wait function console.log 2, and then I'm just going to copy and paste that real quick, 3. And I will wait for you to catch up now. Sorry that I typed fast. So now I have these 3 things, and I'm just running them one after another. What am I going to see on my console? Anyone?
Listed out line by line. Or on their own line.
They're going to be listed out on their own lines, but is there going to be anything interesting about the way that they're listed out?
Different order.
They're going to be in a different order, right? Because weight is random. So I can't write them like this and expect them to go 1, 2, 3, because 3 may only wait for like 3 milliseconds and 1 may wait for 500. And so I'm going to see 3 and then 1 and then 2 maybe, or any random order, right? Who knows how it's going to end up. Every single time I'm going to get different results, and it ends up looking kind of silly.
And I don't have to put error data in every time as function because we call it once.
No, we don't put them in because I don't care about the result. We're just logging this out. I don't actually care about what weight it gives me back. I'm only putting 0 here because we don't have any checking that that's the callback. We could write it so that we didn't need that, but whatever. So if I want these things to happen in order, right? If I want it to be 1, 2, 3, then I got to create my pyramid of doom, right? So I have to take these functions and I put them inside of the callback for the first one to make sure that they will only happen once that's done. So I'm going to come in here, I'm going to paste them. And then if I want 3 to happen after 2, it has to go inside of that callback, right? So it has to get nested again. And so we end up with, the other thing that people like to call this in the JavaScript community is seagulls. Because it's like you've got birds like winging their way in a V across the bottom, right? But this is what I have to do in order to get 1, 2, and 3 in order, because I have to make sure that I only call the next item after this one is done. This may look contrived, but it's not contrived at all, right? Like this is a really standard way that processes in Node work. Like if I needed to read a list of files, and then from that file, maybe I'm going to read a list of URLs that I need to request, like maybe I'm writing a web scraper. So it has a bunch of things that it needs to talk to. Then it goes out and gets those things. I need to make sure that they happen in order. Once those things have been requested, I need to talk to the database and save the results. I'm ending up in this chain of like read file, make request, talk to database, and then maybe after the database is done, like I send that back to the browser. This is actually the way the RSS reader that I've written in Node has to do all of those steps. And so you end up with like 4 or 5 levels if you're not careful, or even deeper. 4 or 5 at least levels of functions inside functions inside functions to make sure that the order is consistent. We should not have to do this. It's really obnoxious. And so the way that we get around this is we use the async waterfall. And it's called an async waterfall because the result of each previous item will be fed into the next one. But it lets us write it, instead of nesting it like this, it lets us write it in a list going down so that it at least looks like, and we don't, it looks like a block of code that reads top to bottom, and we don't get the seagulls in here, right? We get one after the other. So let's put that together real quick. I'm actually going to make sure that that works. There we go. 1, 2, 3. That works. Cool. But I'd like to make it a lot easier. So we're going to say async.waterfall. And waterfall takes two arguments. The first argument is the array of functions that we want to call one after the other. And the second argument is a function that'll be called once it's all done. This first one is going to be an array of functions. It's going to be the array of things that we want to happen one after another. So for example, we could write this where each of these functions is going to be the one that calls wait and then logs something else. So we're going to say, here's a function. It takes C is the continuation, the callback, and I'm going to console.log 1. I'm going to end up putting these on different lines, sorry. And then I'm going to wait. I'm going to pass 1 into it, and I'm going to give it the callback. And I've got another function that gets called, and it gets the data that I passed from wait and the callback, and it logs out 2, and it waits. All right, that's enough. We'll add the third one in a second, but I'll give you guys some time to catch up. So what's happening here, we've got an array of functions, right? A list of functions that we want to happen in order. Each of these functions will be passed the result of the previous function. So wait, remember, when wait calls its callback, it calls it with the error and with the data that we passed in. That means that the next function, any errors will cancel the waterfall and it'll jump to the end. So we don't have to worry about getting the errors inside of async. But we do need to get that data plus the function that we call to tell it, okay, I'm done, let's go to the next step. So we're basically chaining these together, right? Each function gets a callback function passed in as its last parameter, because that's how a node works. And when it calls that, it lets async know, I'm done, go on to the next function. In this case, we're passing that to wait. So wait, when it's done, will call our callback for us and move on to this. This gets it, it logs out 2, it calls wait, and it passes this callback in so that once the wait is done, it will move on to the next function, which I will add here. So we'll console.log 3. And then we will, let's just go ahead and wait for no good reason, and then we'll be all done. So this again, and we'll wrap this up and then we'll take a short break so that you can rest and recuperate from all of this asynchronous thing. It's a little bit mind-bending, right? But conceptually, and so some of the things that can be confusing is, for example, you're seeing C a lot. It doesn't matter because, right, when you pass in an argument to a function, you can call it whatever, and it'll only exist inside that function. So these are not the same function. It's not the same value. It's something that async passes in that's a signaling function to say, yes, I'm done, go on to the next. And these things are then passed from item to item. So that's how they get chained together. So there's a little bit, I guess, of seagulls here, but if this goes on for like 18 functions, they'll still never be any more indented than this. And they will all appear in the order that I want them to happen. And now when I run this in my console, I should see 1, 2, and 3. They get interspersed with the other stuff because the wait is random, but it's still going to happen always 1, 2, 3. The order will always be the same. One feeds into the next. Yes. So by calling that C function that gets passed in as the last item, which is the standard node way, right? The callback is always the last argument. By calling that, we tell async, I'm done with this step, go on to the next one. I'm going to wait. When I'm done waiting, I'm done with that step, go on to the third one, right? Yes, absolutely. Yeah, Jacob, did you have a question or did you just want me to scroll?
Oh, no, I didn't raise my hand.
Okay, Doug?
Are you able to pass data into the?
Yeah, so technically, this function would get the final result. So I'm going to show you guys before we take our break. If you look in the example here, right, in the async, so I've got in the materials, I've got like a whole guide to this, right? The whole lesson plan is basically up in the GitHub repo. So you can go through, you can reread this when you get home and you're totally confused and you forget all of this. Like this may make sense to you now, and then you'll get home and you'll be like, that was just completely bonkers. I have no idea what was going on. That's fine. I have an example here. So this is a waterfall where I am checking to see if a directory exists. Then I'm reading a file from that directory. Then I'm changing it and writing it to the hard drive before it's all done. And so in each stage of this, when I'm using next as the name for my callback function, which is fine. So like fs.stat checks if something exists. So I'm asking if the folder exists and then next. That function then gets the values that stat would have normally passed back, which is an object with information about a file. So it gets that, and if it existed, then that's fine. We don't need to know. If there was an error, it would have gone to the bottom. So then we read the file, and you can see where you can't really see, but at the end of that, we pass in next to read file. So that means that the next function in our chain will be called as though it was the callback to read file, right? It's as though this thing was jammed onto here, but we don't want to have to indent them. So we use this basically as a proxy. This calls next, next calls this. And so now this function gets passed the data from reading the file, we change it, we write it back out. By using this function in our waterfall, we pass data from one operation to the next, to the next, to the next. The output of the previous function gets fed to the next function. That's how you create a chain of dependencies where I can request something, then feed that result to a database, then feed the result of the database back up to the client, that kind of thing, right? So they all go one into the next. How many people are confused? That's cool. No worries. That's how this works. But we're going to get you past it. We're going to practice this a lot. So what we're going to do now, it's 7:09. We're roughly halfway through class. So we're going to take a short break. And when we come back, we're going to let this stuff lie fallow, okay? We're going to let it percolate in your brain. But we're going to come back to it on Thursday. We're going to do a bunch of stuff with async on Thursday in the directed lab. So you're going to get lots of practice and hands-on running these things, logging out the results so that you can actually see like, oh, okay, so this thing came from here, it got into here. This is how information flows through my program, okay? So let's take a 10-minute break. Let's come back at 7:20, and then we're going to continue talking about events and streams as our other two strategies. Yeah.
So because it's waiting for the callback, is it still considered non-block?
Yeah. Because other code could be run during the time. It might handle. There might be like, so if you think about this is what's so like while it's waiting, it's not going to handle so it can be dealing with lots of things.
Yeah, it is. So within that waterfall,
It is still like behind the scenes. It's still actually interweaving that with other people's code or with code that's running for other people's sessions. So you just don't have to care about it. As far as you're concerned, you live in one piece.
Okay.
What's going on?
So is that MP? M?
How do you make this?
Oh, yeah, we have to do it, so, okay. Oh my God, this is, I did it, but I was talking about the
Okay.
No, I didn't say anything. That's what I just like, oh my gosh. So you need to set and then wait there. I have to do the apples too. I have to do the how to use this thing.
Oh, yeah, so save that side.
My neck and shoulder are setting.
What's in there? Yeah, save. What is that?
Wait.
Sorry. CD space. Capital C for desktop.
Yeah, unexpected growth. Oh,
Oh, shit. Oh, God damn it. Come back.
Oh, you're reading this one. So,
Go ahead.
L, CD,
so first you want to. Oh, yeah, I can do it.
Oh, just.
Sorry, no, do it from there.
Huh? Exactly. You sit right there. Does anybody else need copies of that while I'm printing some off? All right.
Oh, what are you printing?
This.
it's going back to the callback. All right, now CD. Yeah, see that's. That's four items.
Yeah. Well, we all have good grades.
Oh, I know.
Unless you got a grade you wanted.
Oh,
Yeah. Dude, all the work that 4 on those tickets. Yeah, all those 60 years on the floor. Yes, I just chopped it all up and like.
When do you stop the
Instead of
clock
like,
ticking
you know, his time.
What'd you say?
When do you stop
Alexander's
the
version.
clock?
When did I stop what?
When do you stop the clock? You stop the
I don't know what you're talking about. I just print out, well, I printed out what he did today because I did not know that. I didn't even think about that, to be honest.
Oh, camera strikes me. Okay. I just, now I feel really ashamed because it looks like I'm doing it. And I just want to make sure everyone I'm not printing out.
Well, they'll see my face, won't they?
No.
Oh, well, it is Thomas. It is Thomas.
I know what you guys screen share. So yes, I know.
Yeah.
Okay. So,
It's gonna take so long to install. Well, it all depends on what happens there. It all depends on what happens next. You know, like I said, all your video. One set of. Oh, I'm sorry.
Shit.
So I'm not taking this. One second. Well, I'm doing Unity.
But this one is right. No, this one is right. No, I mean, what's your, name? No.
Special presentation. So
it's like a family stuff.
Or you're gonna do all the additional.
Yeah, you open and
Right, yeah.
it actually makes it a lot easier.
This is basically like, contact because
Yeah, well,
so they don't have like an internal.
I get it. And my server was.
Now I know.
I could be able to see.
So it's the same. Okay.
But it's mostly like learning. Debugging. Yeah, you learn a lot. Debugging. So VBA is basically about
it's not really like oh, you program right, so it's now.
Yeah. So like
Part of it is.
Collection of things.
all the validation for everything. Not, there's nothing. Oh, really? It's not, there's no validation. You gotta, like, so right now, this stuff doesn't refresh, and I don't know exactly where to try That's just one of these events. It's like 50. Because basically you have to require the data.
Where do you get started?
So then
oh my god.
because like usually like to have it on each one of so basically everyone gets a copy.
It's actually.
Yeah.
And so,
I don't know. I'm trying to recreate.
but you're still limited now.
Yeah, it's not seeing.
We would, in order to crash. We were actually running. It wasn't slowing down.
I know, well, we haven't, I put it all this way.
Yeah, that's really part of our position.
Were they?
Let's get into form. Okay, 7:22, a little bit late, that's cool. So what I want to do now, first of all, is I want to turn off the screen share because it turns out that I have been probably doing like the crazy hall of mirrors this whole time. So that's awesome. So let's actually switch to the entire screen real quick. There we go. Now we just get infinite grumpy cats. Cool. So what I want to do, I'm going to create a new module that we're going to work with, but we are going to use the request module in this new script that we're writing. Somebody's been editing my weight. Why are you copying? Dude, seriously? You're messing with my weight.js, man. You're messing it up. It's okay, don't worry about it. All right, so we are going to go out and we are going to get some web pages. Right? We're going to actually start getting our hands a little bit dirty here. So to do that, Node comes built in with HTTP and HTTPS libraries, but they're kind of clumsy to use, to be honest with you. So we're going to create a new file. We're going to save as get.js, for lack of a better term. It's fine. And then from the console, we are going to install a new module that we haven't used before. And that module is the request module. So I'm going to say npm install, or for those of you on a Mac, sudo npm install. I'm going to install request, and I'm going to save it, right? Because I need to save that to my package.json so that I can restore it later. And this is going to be a lot more stuff. Like request includes a lot more stuff.
I'm just getting an error.
I will come over to help you. The library is called requests, so it is right here. Hang on. Once it's done, I'll run this again. There we go. So run npm request -- save. Npm install request. Oh, your package.json file. So go back to that. Oh, it's did you delete it or something? Okay. Don't worry about the same. Cool. All right, so you're going to install this. If you can, you're going to save it. And so this is going to make a request module available to you. We used request a little bit the other day. Are you still having problems? Okay. We used request a little bit the other day. It is a library that is All right, so request is a library for going out and getting stuff off the internet. And we used it the other day to go out and get a web page, right? So for example, we might say, we're going to get that, we're going to load up that module. So we're going to say request equals require request. And then to use it, the traditional way of using request is just to pass in a callback. So we've done this before where we've been like, okay, so, whoa, all caps, request, and we might say, go and get google.com, and then the callback function will get the error, the response, and the body, and we can log out the body. And that's a request. So this is the traditional node-like way of using this library, right? I have one URL, and I want to go and get that URL, get the contents, and then it will come back, and I'll be able to get the body of that, meaning that the page source will come back in the body. And so when I run this, if I come back here and I say node get.js, hey, look, it's the source code to google.com, which is a nightmare. Yes, absolutely. So if you've ever wanted to see the horrifying monstrosity that is the source code to google.com, now's your chance. Yay. But request actually offers, in addition to this like normal, traditional callback functionality, request also provides a way of handling these things that's based on events. So events allow us to deal with not only, right, so a callback can only be fired really once, right? Like this request goes out and it completes, like it's totally done, and then we get the body. But we're only notified once. We're notified like, okay, this thing is done, here you go. But what if we wanted to basically know about the progress of it, right? Like what if we wanted to know as this request was coming in, which could happen, right? Like what if we were downloading a very large file? And so we wanted to know every so often, like, oh, you got some data. Cool, I can update like a progress bar, right? Which is originally what Node was actually designed for. When it was first invented, Ryan Dahl at Joyent was trying to handle like uploads in the browser. And so he wanted a solution where lots of people could upload big files and then he could still fire off notifications back to them saying, okay, yeah, you're 60% done now, right? And so he needed to be able to, whenever he got, he needed to be able to know, like partway through that transfer, like how far am I done? And to be able to save it and to handle lots of these things. So let's take a look real quick at the request documentation. Let's look at some of the events that it offers. So I'm gonna go to github.com/request/request. I know because I've spent way too much time dealing with this library. All right. And so the other way that we can do this actually is we can receive events. And events mean that we will get notified when certain things happen. Instead of getting it all in one batch, we can break our code into individual chunks that happen in stages. So for example, here, they're getting like this Google image, and then on the response, they just want the response, and they don't care about the error, because you can see down here, they can also listen for the error event and handle that, right? Like we can handle those two things. Ignore the pipe for now. But those two things are two different events that happen for one request. And we can, instead of handling them all in one big function at the end, we can handle them in chunks, right? Or we can handle them in individual pieces. So let's go ahead and do that. In that case, we're gonna comment this out real quick. And we're gonna create a new variable where we're gonna say this request is request.get, and I'm gonna get, actually, I'm going to look at google.com. I'm going to see if there's actually like a thing that I can grab from it. Except I can't get back to my browser, so whatever. Should really, some line breaks in. There we go. And then request dot on error, function error, console.log. So now when I make this request, instead of passing in one callback, I can register for multiple events. And I can just say, yeah, that's totally cool. I would actually like to get like the image or something that's, it would be nice to have something more specific, whatever. And so I should see when I run this code now, I shouldn't see the error thing gets called at all. But there's the response, which is an object saying like, okay, here's the response that came back. And so this is, I got the headers. I can probably pull the body off of this object. But this is the first object that I got off of, like in my callback, I would normally get an error, a response, and a body. Now, instead of waiting for like the body to finish download, for example, I can just wait and I can say, look, once you've got a response, let me know. And if you have an error, let me know. But I don't have to have one function that handles both of them because I'm going to listen for events. Hopefully, you guys remember from Web 150 the way that we handled events in a browser, right? So normally in a browser, we would write some jQuery. And we might say, okay, so I'm going to use jQuery. I'm going to select for some link tags that have like a thumbnail class. And then on click, I would do something, right? Or you might have just used the click function, right? But you would have used one of these two things. So this would be in the browser how you would register for events. You would say, on this event, I want to do this thing. And the reason that we would use events in the browser instead of using callbacks like Node does is because you can click on that thing multiple times, right? We don't want to be like button.click and then pass in a single function and it only gets called on the first click as though one click only ever happens. We register an event because events can happen multiple times. So in this case, we might have things come back multiple times from response. I'm just going to try something real quick here. I'm going to say request.on data. Do not type this .bind console. I'm just testing something out real quick. See if this works. It should. There we go. Cool. So I know, right? That's terrifying. Let me spell this out a little bit more. Function buffer console.log buffer.toString. On that again. Oh, there we go. Cool. But first, I'm going to add like a big thing to this. I'm going to be like buffer. So if I tell it that on data, it means that instead of processing this thing all in one chunk, I would like to handle it in individual pieces as those come in. So like you can see here, this is one buffer chunk. We'll add some new lines here so that it's more obvious. Run that again. So here's a chunk of code that came in, right? Because this can't all download in one single packet. So from the network, it gets sent in pieces, right? That's how networks work. It's not like one big chunk happens. Like the browser behind the scenes is going and it's receiving multiple messages with little pieces of the file and patching them together, right? That's how, maybe you don't know that, but that's how when you make an HTTP request, it comes in several chunks. Instead of dealing with these chunks as one long piece, we could actually deal with them one tiny bit at a time. So in this case, we're getting this string, then we're getting this next chunk, then this next chunk. They're sized differently, which is kind of funny, right? But we get it in actually like 4 individual pieces. So we can process this not as one huge file, but as the individual pieces of data come in off the network, we can process each one in turn. And for web pages, to be fair, that's a really useless thing to do most of the time. But it is not useless for a lot of other cases. For example, if you were transcoding video, like if someone was uploading video to YouTube or something, and you needed to handle each frame and run a filter, right? Like let's say that your startup idea is you are going to be Instagram for video. So you're going to filter this video. You don't want to wait for the whole video to be uploaded before you filter it, because that's going to take you a really long time. And if it gets interrupted, something could happen. Plus then that ties up a computer. So you actually want to filter it as it comes in, right? So you're going to register for the data events and then process each little chunk of video and then pass it on. You're going to be like, okay, I'm done with this now. We'll save it to the hard drive or whatever. But that way, instead of processing one big video, you process little tiny chunks of video. So events are a really common way that we also handle asynchronicity, right? One way has been that we use callbacks. We use async when we have multiple callbacks to juggle. But another thing that we do a lot of the time is we will register for events that will then be called multiple times. So you can do that on file uploads. If you're processing spreadsheets, I use this for CSVs, and then I get an event for each line. And so I can handle each line of my spreadsheet individually and then piece them all together at the end. So there's lots of cases where we're going to register for events on certain modules and use them instead of necessarily just passing a single callback. And that's going to depend on the module. So sometimes this is, sometimes modules don't use this. Like some modules think that they don't want to deal with events. They only deal in callbacks, right? The async library is all about callbacks, and it doesn't care anything about events. It doesn't dispatch them. It doesn't care about them. It doesn't trigger them, nothing. If you listen for events on an async, you'll get nothing. But a lot of things that have long-running process, they will use this as a way of processing data as it comes in. Whenever you see, so this is another standard that's in Node. I was just saying during the break, if you use, in the browser, we have a lot of different ways of handling events, right? Like if you use jQuery, you have the on function. So you can say on click, on mouse over, on key down, whatever. And then if you use YUI, you have, there's a different kind of event listener that you use to or a different function name that you use to register event listeners. I don't remember what it is because I hated YUI. But regardless, it was different, right? And then if you were doing it directly in the browser, you might use the add event listener function, which is the standard in the browser. You would say add event listener click. And if you're not using jQuery, that's what you use. So you've got all these different function names for attaching to events, right? Like everybody disagrees, nobody has a standard. In Node, we have a standard. Every time that you see a function that is on, that means that you are registering an event listener. That's how you do it for every single module. You will never have to use add event listener or anything other than on when you want to listen for an event. So that's going to be the standard way. And this is actually documented in, if we were to go over to the Node docs, so if we were to go to nodejs.org, I always get this wrong and then it's, oh, cool, it worked. So if we look at the API docs, there's a section for events, and these are the kinds of things that all event emitters, which is a kind of object in Node that has events, right? They all will use these same things. They'll have on. They will all have a once, which means that you can have it where it will only fire for that event once and then it unregisters itself. So it acts like a callback. They have a remove listener and remove all listeners. And then they have emit. If you wanted to make something that actually fired its own events, like you wanted to make your own events, you could create a new event emitter and use it to dispatch whatever events you wanted. That's probably way in your future, right? Like you're not going to immediately sit down and start writing yourself some event emitters. But it's a standard. It's right here. You're never going to have to guess, like, how do I register events in this module? It will always be the on function. And it'll always be documented in the documentation for whatever it is that you're dealing with. Any questions about events? These are pretty straightforward, right? Like there's nothing terribly crazy about events. They're really pretty, especially once you can, like, honestly, these are much simpler. I think a little bit more limited, but much simpler than like the normal callback thing where like you're passing callbacks around and a lot. This is really, like it's almost always just one level deep. You listen for an event, you deal with it, you move on, right? But this leads us to the last way that we handle asynchronicity. in Node.js. So the last way that we handle the fact that Node doesn't wait for us, and that is streams. So let's go back to our hypothetical scenario where we are uploading a video to a server. So I have like Periscope or Meerkat or whatever it is that the hip kids are using these days, right? So I have my phone and I have it out and I'm videotaping things and I'm uploading to this server which is running Node.js. And the server could be running a filter, but let's say that it just wants to save that video file, right? Like it just wants to get it out of the upload and dump it straight to a file. So it just wants to say, yes, like throw this thing away. Or download it and stick it there and I'll do something with it later. It doesn't want for the whole, again, it doesn't want to wait for the whole upload to complete because that would take a really long time. There might be an error, something might go wrong. It wants to do it a little piece at a time. And then if something happens, it'll deal with that. But it wants to capture, it also doesn't want to like spend all the memory to hold that because your JavaScript requires RAM for all of these variables. So if you wait for the whole upload to finish, like who knows, now you've got like a 3 gig memory file and your server crashes. So we want to deal with it in individual pieces, or we just want to hand it off. We just want to be like, look, here's the input, here's the output. Node, take care of connecting these two things together. That's what a stream is for. So the requests library works in streams, and we can use it like this. I'll show you something real quick. So we're going to say, in addition to requests, we're going to load the built-in file system module. So we're going to require FS. And we've used FS before to write files and to read files using callbacks. So we would say like read file, and then there would be a callback and we would get the contents of that file. Or we would say write file, and then the callback, once the file was done writing, that's when we would get our callback to make sure that it had all made it to the hard drive. But there's another thing that FS can do, which is that it can create a stream. So we're going to create an output. We're going to say, I want to create like a pipe that I can send data to, and it will go to a file for my upload or my download or whatever. So I'm going to say var output is equal to fs create write stream download.html. And then I'm going to take my request that I made up here, right? So I got an object that's an event emitter. It fires events. But this object is a stream, meaning that it is you can think of it as like a pipe, right? Like, how many of you have played Pipe Dreams? Anyone remember like the old game Pipe Dreams, where like there's like goop coming in and you have to like spin the pipes around so that they get connected, so that it gets all the way through the system, and if it spills, then you get, yeah, like some people remember this. Other people are looking at me like I'm crazy. That's fine. Happens all the time. All right, so the other thing that this may, if any of you are music people, this is a lot like a synthesizer, or like hooking up like your stereo at home, right? Like you've got, so I've got my stereo here, and it's got like an output jack, and then I've got like my or it's got an input jack, and it's got output, and the output goes to the speakers. So here's my speakers blaring my music. And then I've got my DVD player here, and it has an output, and so I patch my output from my DVD into my stereo. My stereo gets piped here. These are streams, right? And when I use the pipe method between streams, basically what I'm doing is I'm connecting a cord from one of these to the other so that a signal flows between them. And it goes from one to the other. There's more to it than that, but for right now, that's a really useful way to think of it, is I'm just wiring up my home stereo. For those of you who hate wiring up your home stereo, this is slightly less confusing, but probably ultimately maybe slightly less satisfying. You don't get to like watch the Avengers when you're done with the pipe, unless something's going on that I'm not aware of. So we're going to take our request, and we're going to pipe it to our output. And that's all we have to do. So we don't have to worry about like normally if we wanted to write this out, like when we've done this before, we requested, and then in the callback we got the body, and then we we used fs.write file, and we wrote that data in, and then we had to check that it was closed. In this case, we just say, look, I'm going to make a request, and we don't even actually technically have to listen for these events, right? Like I don't actually have to even care about them. I just make a request, and then I create an output. So I create an input and an output, and then using pipe, I connect those two things together. I don't write any more code. Node will say, okay, I know how pipes work. I know how streams work. So if I have an input here and an output here, you don't have to write the thing that like copies stuff from the input to the file. It knows how to do that, right? Like because it's a stream, it's a standard way of doing it. And so now when I run this, it's going to exit, but you're going to notice that now I've got a big old download.html file sitting here. Because that's what I did. I took my incoming request and I piped it to this file. And so it, as that request came in, it wrote it to the file. And then when the request ended, the stream closed. And it saw that, and it finished, and it closed out the file for me and exited. So being able to write pipes and pipes, like in this case, these are actually, so I talked about how these are standard events. They're actually standard events on streams, right? Like most streams will issue a data event as stuff comes in through the stream. As signal travels through that wire, it's going to let you know. And there's an event for when it's done. Like there's a on finish that will tell you, yes, this stream has closed, this download has completed, you can clean up or do whatever it is that you want. Yes?
Quick question, how do you do the multi-line comment thing?
Oh, the multi, you mean how did I do this?
Yeah, you just comment with multi-line.
I select all of them and then I hit Control/ or a Command/ on a Mac, and Adam will do that for you. So will Sublime actually. It's pretty great. Command Shift/ will do the like bracket comment, but whatever. So if you are writing something that needs to basically just download a bunch of files, you can see all of a sudden how much easier this is, right? Like I don't have to worry about like getting each of those files and reading it into a variable and then writing a new file from it. I can just pipe it to an output stream and they connect together, and Node takes care of wiring those things together. So being able to connect streams like this is tremendously powerful. One, because it means that's all the code that we didn't write, and code that you don't write can't have bugs in it. So I'm not going to run into any, like, I'm not going to miswrite something here unless I misspell pipe. But I'm not going to have to worry that like I screwed something up in the middle of taking that data from one place and putting it in another, because all of that stuff is handled at a layer underneath me that has been written and tested very, very carefully to work. Right? Streams underlie a huge amount of stuff in Node, so they're really well tested because if they break, everything breaks. But the other advantage of it is since I don't run any code, this is super fast. Because code that you don't write is also code that can't be slow. So since all of this happens at an underlying level that's all written in C++ and it's super optimized and people spend a lot of time making it very efficient, when I pipe something from one place to another like this, I know that it's not going to be a case of like my server's going to crash most of the time, because pipes are very efficient and I can't slow them down really. There's nothing I can do to make this all of a sudden like a really, to take up computer time and clog up the server. Like this is going to be the most efficient way of taking something from one place and putting it in another. So these are our three ways of handling asynchronicity, right? And they tend to combine. So we've got regular callbacks, but those are the base layer. On top of that, we have the async library that we use in order to handle lots of callback-based stuff. But then on top of that, you can mix and match these, right? You might have an async process that uses request, pipes it to a file name, and then calls the callback to let async know it's done when the stream ends. So it would know that it ends because there would be an event, right? We would get a request.onFinish function console.log. All right, so we would listen for an event to know that it was, well, that's the wrong event, but whatever. You get my point, is that it would end, right? Here we go. It'll know that it's done with an event, but it pipes it with a stream. And then if we have lots of those files, we might be organizing all of their downloads via async. All of these things get mixed and matched, right? You have all of these three basic strategies of managing this kind of like callback soup that we tend to get revolves around these three kinds of abstractions for asynchronicity. So we've got the async library, we've got events, and we have streams that fire events and other things that fire events. Questions about any of that? Other than, can you restate everything? I'm totally confused. That's okay. It's not a big deal, right? I get that. Like I said, this is not natural. And especially if you've come from other programming languages, this is really weird. Like, this is a very strange way of coding, and it took me a while to get the hang of it. And it'll take you a while to get the hang of it. But that's why we're going to have the directed labs. That's why I'll have office time for those of you who can't make it on Thursdays, if you're in the independent study, right? We're going to have time where I can sit down and work through this stuff with you. It's going to take some time and some patience. But once you get it, then you can write all of this stuff in Node, and you can take advantage of all of the power that this language has for doing stuff on the server. So I wanted to, let's take a look at the other stuff that is in my materials real quick. So we talk a little bit about waterfall. So in the async directory, right, I've got in the 298 materials, I have, last week we covered the intro to Node. There's a lab in there that I know some of you started, but it's okay if you didn't, right? Because we didn't have a lab last week because I was out of town. We will have a lab this week, and I'll probably rewrite it a little bit. But in addition to that, now we have the async folder to cover the stuff. And so in addition to the basic README file that you look at when you open this folder, there is also an events.rst that goes through, and it talks about the different kinds of events that we get, how to listen for them. We create an event emitter. There's an example of that. So this creates our own thing that can actually fire events, and then we listen for those things. And then it also talks about streams and piping things around. So I talk about how I parse the CSV and then pipe it from one place to the next. So all of this material is available for you in case you get confused or you need to review it. Right? It's all been written up. And if there's anything in there that's still unclear, please send me a note or practice your GitHub by filing an issue. Right? Put up an issue with a bug report saying this is confusing, and then I'll fix it and I'll close that issue. So we'll start collaborating on this text that we're using for the class the same way that we collaborate on code, which is a big part of how I like to work these days. Okay, before we leave, we've got like 20 minutes left. And so we've talked a little bit about pipes and outputs. What I want to do now is I want to combine all three of these things. So we're going to load a file. We're going to process that file, which is a list of URLs with requests, and then we're going to download those things and put them on the hard drive. So we're going to do this real quick. It should only take about 20 minutes. Go ahead and with me now, let's create two new files. We're going to call one of these is combined.js, and that's going to be what we're going to work on right now. And then the other one is going to be save it as urls.txt, and that's going to be the list of web addresses that we want to go get from the network. So we've got combined.js, which is the script file that we're going to write and that we're going to run from Node. And we've got urls.txt, and this is going to be the list of stuff. So I'm just going to put in some quick URLs. I'm just going to be like thomaswilburn.net, seattlecentral.edu, and google.com. And you can put in whatever URLs you want. I would suggest doing like 2 or 3. It's not a big deal. Okay. So now let's think about what we're going to do here. Is it's a straightforward sequence of events, but going through and thinking clearly, like kind of putting together a flow chart, is really, really helpful when you're dealing with a lot of this asynchronous code, because it's very easy to get confused really quick. So we want to like sort through it in our head, and then we can put it into our actual code. So the first thing we're going to do is we are going to read this urls.txt, right? That's async. I'm going to like tag it with a little star. And then we are going to take that URL and we're going to split it into lines, right? So then for each line, we will have a URL. So we'll have a web address that we're going to download for each one. Then we're going to use request, and for each URL, we are going to request it. We're going to create an output. We're going to pipe that output to, or we're going to pipe the request, so we're just going to download it, right? We're going to use our streams. We're going to say, hey, get this address, pipe it into this file. I don't want to do anything to it. And then when they're all done, so this is another thing that has to happen asynchronously, right? Because requests take time over the network. They're not blocked. When they're all done, we're going to let you know. We're going to log out any errors that happened. So those are the steps we're going to go through. So to do this, looking at this set of events, what are the modules that we need? Not all at once. We need the file system, right? So we need FS. We're going to need async, right? Because we're going to be doing things asynchronously. So and especially when we split the URLs into lines, it's going to be an array. And so processing arrays is the kind of thing that async is really good at. So we're going to say, we're going to go and we're going to get async from our modules. And then obviously, if we're going to go out over the network, the last thing that we need is requests. Now I'm going to load one more thing that we used last week that we haven't used so far today. But when I get these URLs, I want to download them into individual files that are named after where I downloaded it from. So I need to take that URL and get a valid file name out of it. So I'm going to require the URL library, which is built into Node. And it will let me parse that URL and turn it into something that doesn't have like HTTP at the front of it. So it'll let me chop that off. It'll let me chop off the path, and I'll just get the domain. So let's do this. Actually, we're going to start with a pyramid. So we're going to start by reading our file, right? So I'm going to say fs.read file. I need to tell it that I want to read urls.txt or whatever it is that you named your file. Anyone remember what comes next? There's a gotcha with read file, right? Right, we have to tell it what encoding we're going to use, which is a total pain, but we can't get around it. So we have to tell it, look, this is a UTF-8 file. If we don't tell it UTF-8, we get buffer. So it'll hand us just like raw binary data, and that's no good to us. We can't use that. It's useless. So we're going to say UTF-8. And then we're going to get a function with the error and the data. Actually, let's call this file. That's what it is, right? It's the contents of the file. And one thing I want to stress, and hopefully if you've had class with me before, this is going to be really familiar. We're going to be testing this as we go along. We're not going to write all of this code at once and then just be like, I hope it works. Because that is an easy way for it to not work. And now you have 40 lines of code and you have to figure out where the bug is, right? So we're always going to write like 2 lines at a time and then run it and test it just to see what's going on. So in this case, all I'm doing is reading the file, and then I'm going to make sure that the file got read okay. So I'm just going to say node combined.js, and there we go. There's my file, right? So we immediately just console.log, and then we'll get rid of that console.log. We're not going to keep it around eternally. But I just want to go through and be like, yes, I have in fact read a file successfully, because if this breaks, but I've written 20 other lines, I might have to look through those other 20 lines when it turns out that the first one was broken, and then I feel really stupid. So we want to check ourselves constantly. And that's one of those things that honestly, like, I feel like we don't stress enough. Like, we talk about like as though, and you're going to see me a lot of times, like, I'm going to write a whole bunch of code, but I've done this for a really long time, right? When you're first starting out, or when you're new, or clearly when I have like the wrong event or something, I do this all the time. I get stuff wrong. You're going to get stuff wrong. Don't write a whole bunch, right? Write in small chunks and test. That's how you get better without getting super frustrated with yourself. So now that we've got our file, we're going to move on to our second step. We're going to split it into individual lines. So I'm going to say var list is equal to file.split on hard returns, so on line breaks. And then I'm going to console.log the list, because I am seriously nothing if not thorough. And when I run this, I should see an array of, I actually have 4 items because there's an extra line break added onto the end, and we'll just check for that later. That's not a big deal. But yeah, so we should see an array of all of those items plus the trailing line break. I think Adam adds that for me without asking me, so we'll just work around it. It's not a big deal. So you should see something that looks basically like that.
Yeah.
Okay, cool. All right, so now we've got this list. We've got an array of things, and we want to do something with them, right? We're going to make these requests. So that means that we need to use async to go through and perform an operation for each one. We don't need to save it into a new array, right? We're not transforming because we're going to write them out to files. So I'm going to do 2 things. I could do this early, but I'm going to go ahead and parse this. So I'm going to go ahead and I'm going to say address is equal to url.parse. Oh, no, never mind. I'm wrong. Skip that, delete that line. We're going to start our async, and we're going to go through this list. So we're going to say async.each. And for each item in the list, we will call this function. We will get a line and a callback. And then at the end, this will be our final callback function when they're all done, right? So this is when they're all done. This is called for each item. Async.each, we have our list. The first function gets called for each item in that list. The second function gets called when all of those items have been completed. So when all of our downloads are done. Okay. So for our for each item, we need to do 2 things, right? We need to, well, 3 things. We need to figure out a file name to save it into. We need to request it. And then we need to create an output stream and connect those two up to make the download happen, right? So we're gonna have our output, we're gonna have our request, and we're gonna pipe one to the other. So first, let's go through and let's get our parse all of our items. So we're gonna say if our parsed is equal to line or URL.parse line console.log parsed. So I'm going through and I'm saying, hey, what is that URL? What is the address for that thing? What are the parts of that address? And URL.parse will break it into an object for us, right? Similar to window.location if you use that in the browser. So it's going to have like, what's the protocol? What's the domain? What's the path? Is there a port number? All of those kinds of things. And when we go through and we look at it, here we go, right? So you've got like, here's google.com is the href, and the host name is google.com, and the protocol is HTTP, right? We're taking this string and we're breaking it into its parts. We're parsing it. And that's good because that'll give us the file name that we can create our file with. Using that now, we're going to go through and we're going to create a file stream, an output for where our download goes. So we're going to say var output is equal to fs.create write stream. And we want to know where it goes. And so it is going to go at parsed.host plus.html. If you look at the console.log output, the host is the domain name, right? So google.com, thomaswilburn.net, seattlecentral.edu. So that means that the outputs that these requests are going to get sent to are going to be google.com.html, thomaswilburn.net.html, and seattlecentral.edu.html, right? Those are our outputs. That's where the file name goes. It's okay, but it's really going to be helpful for this class if you don't know how to touch type. Sorry, I go really fast. Please feel free to tell me to slow down because I don't think about it sometimes.
No, I think it's because errors here.
Okay.
I was trying to think where I think when the screen moves a bunch, not so much that you go too fast, but then.
So in this case, it's that you've got praise instead of parse.
Uh-huh.
And so it'll actually point to that, right? It'll be like, has no method praise.
Okay.
There is nothing.
Yeah,
no problem.
Like my vision's going.
No worries. Happens to all of us. We're all getting old. Okay. So now we need to, you like that one, huh? So now we're going to go through and we're going to actually request this thing and we're going to pipe it through. So let's create our request. We're going to say request.get and the line. And from that request, we can pipe it to our output.
REQ basically is just required.
So REQ is when we, do you remember when we did you have me for JavaScript?
No.
Oh, when you did jQuery and you did Ajax?
Yes.
Would you do like var request equals $Ajax?
Yes.
Okay, that's what this is.
Okay.
It's the REQ is the request object, so it's monitoring, like it represents this network request is going out and then coming back. So it's how we keep track of which requests we're dealing with. Good question. So we pipe the result of that to the output. And how do we know when it's done? We listen for an event. So we say request.onEnd. And we're actually just going to call, we're just going to pass the callback. We're just going to say, look, when you're done, call the callback that tells our async.each that it's all finished. So this may look a little strange, right? Like I'm taking this one thing and I'm just kind of like jamming it directly on here. But it's actually, if you think about the fact that this function is a value, right? I'm just taking one variable and I'm passing it from one place to another. The only purpose of that callback function is to signal completion. So I could, if I really wanted to, I could write a whole function here. Don't do this. I could write a function that just calls callback, right? Like I could do that. But what's the point? Like why bother wrapping it up when I could just have requests call it for me? So just by passing it through, I say, look, I don't know when I'm done. You do. You take care of signaling that this request is completed. And then finally here, let's if there are errors, let's log them out. But otherwise, let's console.log that we are all completed. And there may be an error here. I'm not entirely sure. I think that last line is going to give me a bug, but that's okay. That's how we learn. I'm just going to run this real quick. Oh yeah, that's what I thought. Unhandled error event. Cool. So it really doesn't like having that blank line. We're going to add at the start here, we're going to say if a line is empty, then return callback. Let's see if that works. That did it. Cool. So why do I have this? Remember, I have an extra line. There's an empty item in my array, right? Because there was an extra line break at the end of it that Adam added for me. So there was like an empty line. I can't make a request for an empty line, right? Like if I request nothing.com without the .com, I don't get anything. So I have to filter that out. So I have to check, like, okay, if this address didn't have anything in it, then let's just like quit. So we're going to return. We have to return by calling the callback to let async know, look, I'm done with this. In fact, I was done really quick because I didn't even have to do anything. It was not a valid address. It was an empty string. Okay. Let me, I'll just show you guys real quick and then I'll leave this up here and I'll check on what's going on with her. You should end up with individual like something.com.html in each of your directory, and when you open them, you should see a copy of that file. So if this worked, it should have downloaded all of the URLs that you typed in and then put them in files ending in HTML. So because you yeah. It's it happens. Anyone else having errors? Victoria? Mahala? Okay. What's your So it says cannot call method split of undefined, and that is because list is equal to 5 of split \n. Oh, hang on. You have urls.js, but it should be urls.txt. Because that's what you're reading here. If you read it as urls.js, that will work. There you go. See? Easy fix. Okay. Look, it's 8:15. I'm going to come around for people who have bugs. I'm sorry for keeping you so close up against the deadline. On Thursday, feel free to go home, like read up on the stuff, read through the stuff. On Thursday, we are going to build one of these in small groups. All right. So you're going to do it on your own. You're going to have the full 2 hours to come around and help you. So we're going to make sure that you get good practice using these 3 things, but please read the resources that are in the repo, right? They'll help you. If you're here and you need help, I will come around. Otherwise, I'll see you on Thursday. Okay? Thank you for your time.
Honestly, it would be better off sitting in the drive.
I'll probably just do
So where are we? Thursday afternoon.
Yeah, why? I don't know what's going on with that.
Dude, like, one file. Oh, I see.
I don't know. Yeah.
Anybody here going towards Union or Lake Union? See you later. Are you leaving?
Anyone else need me to come around? Jacob, and we got for it. How you doing?
Good, how about you?
Good.
Oh.
Are you done?
All right, so what do you got? So you've got,
We're,
what's this?
Oh, nice. Maybe you call that.
You just made it believe.
No.
How many shows did you say?
not very much.
Okay.
I think that would be a good question. So you have an unreal error, so what's that?
My dear, how
So
are
if
you?
errors are coming in.
What are you?
We'll say request stuff.
Okay, see you later. Have a good night.
So David, oh. Split slide, that needs to be an X. All right, if you split and it's a forward slash, then that's actually a backslash. Have you used a staple character before? Mistress? So for like hard return to a backslash in, if you need to put a quote in here, you do a backslash quote because you have a regular quote string. So this is a special character name, split it on line space. And that's how you get each of these. Okay. Makes sense? Yeah. Awesome. All right, Victoria, what's
It's
up?
the exact same thing.
Since there's nothing wrong, and so that's why
It didn't even count what it is.
so it doesn't work. My name is not
Did it just count on one?
Pilgrim.
We did.
Okay.
So it's just one.
But now.
Yeah, I know.
No, I'm just kidding. It's not.
You know, learn Russian.
But for what reason? I'm never gonna go to Russia.
Because
I mean, you know,
part, yeah,
Russian.
Russian.
Well, I mean,